Alright, so here we have the ionic bonding puzzle activity, and let's take a look at this. So the background, ionic compounds are made of a metal, and non-metal, and we all know that. When the atoms react, they form ions that are charged. Metals tend to form cations, which are positive. Easiest way to remember this is cations, if you spell it out. Cat has a plus in it, so it's T, right? It looks like a plus, so it's a plus positive ion. By donating electrons, nonmetals are anions, which are negative. There's no great way to remember that. Just remember, um, I guess onions are make you sad, which is negative if you cry. So if you cut onions, it makes you cry, which is negative, which is sad. By accepting the electrons that were donated by the metal. So with this information, we can go on to this worksheet. So this procedure, you can read this if you want, but I'll be explaining how to use, or I'll be going over specific examples that I want you to know for the test. So there's no need to read all that if you don't want to. So let us talk about some analysis questions. Number 1. What is required for an ionic compound to form? Hint, charge. This question is asking for the charge-related aspect of ionic compounds. You have to understand here that electrons, this is the abbreviation for electrons. Electrons cannot be created nor destroyed. Destroyed. All right, and this occurs because they can only be transferred. That is the definition of ionic bonding. You transfer electrons, you don't destroy or create them. With that knowledge, we also need to know that the plus and minus, so the positive and negative, charges must be balanced. Must be balanced. So this means that the charge is net charge. I'll actually say net charge equals 0. So based on this information, what is required for an ionic compound to form? Well, we have to have a net charge of 0. Can an ionic compound ever consist of a cation or anion bond? Why or why not? Well, so in order to understand this, we have to define ionic compounds and ionic bonding. Ionic compounds only exist because the ionic bonds occur due to, so let's write here, bonds occur because, so BC, because the electrostatic attraction is attracts oppositely charged ions. So what that means is a sodium with a 1 plus attracts with a chlorine with a 1 minus. So because this positive and negative want to attract each other, that's the whole concept behind ionic bonding. So with that information, we know that so the electrostatic attraction attracts, that sounds weird, but this in the end holds these ionic compounds together. So because these positive and negative are attracted, this holds ionic compounds together. All right, so with that information, we can understand that these ionic compounds have, so as we talked about in question 1, the net charge has to be 0, right? So in order for that to happen, we can't have a cation or cation. So for example, say we have sodium 1 plus and magnesium 2 plus. Our net charge here is 3 plus, which is not 0. We can't ever get 0 if we have 2 positives, right? Both cations, right? We're never going to have a negative, which means we're never going to have 0. Similarly, anion and anion, we're going to have, say, let's take a look here. We have, I don't know, oxygen 2 minus and chlorine 1 minus, right? This is going to have a negative 3, so 3 minus charge, which doesn't equal 0. We're not going to ever see a positive here, which means we're not going to ever get a net 0 charge. So can an ionic compound ever consist of a cation or cation only or anion only bond? No. And that's because, of course, we talked about how we have to equal a net charge of 0. So no. Alright, so research and show the formation of 3 ionic compounds that you use in your everyday life, yada yada yada. You can Google this, but I'll give you 3 examples really quick. So first is sodium chloride. This is table salt. Sodium chloride, which is consisting of sodium 1 plus, Na1 plus, and a chlorine 1 minus. Next one here, 1, and then next one here, 2 down, is baking soda, which is NaHCO3. NaHCO3, that's baking soda, baking soda here. All right, and this actually HCO3 is a polyatomic ion. That's the bicarbonate polyatomic ion. We're going to have Na plus and then HCO3 minus. So these here, let's separate these here. So these here gives us the whole compound of NaHCO3. Last one being, let's see, something not sodium. Magnesium hydroxide. Let's do magnesium hydroxide. MgOH2. This is magnesium hydroxide. So milk of magnesia. And you're probably like, what in the world is that? But this helps treats like constipation, and it works as an antacid as well. But we have Mg here, and we know that hydroxide is a polyatomic ion, so we have 2 OH minuses. And so these are 3 ionic compounds that you use in your everyday life. And we know they're ionic because why? We have metal, sodium, sodium, and magnesium. Moving on. All right, let's try these wonderful practice questions. Move this over to the side. All right, we're going to go through like 5 examples that I came up with that you probably want to know for the test. And we're going to start with aluminum as our cation. Aluminum. And we're going to pretend this has a 3 plus charge. Well, it does have a 3 plus charge. So our anion is going to be chloride. So this has a 1 minus charge, as we all know, because it's a halogen, and halogens have a 1 minus charge. And we're going to try to come up with the number of cations, anions, the chemical formula name, and the electron diagram. So in order to balance this, we know aluminum has a 3 plus and chloride has a 1 minus. So for every 1 aluminum, we need 3 chlorides. So it'll give us AlCl3 as our formula. This name is aluminum chloride. For your Chem 1 purposes, you literally just combine these two and write it as the name. And note that chlorine, it's not chlorine, the ion is ide. It ends in IDE. It's so you'll learn this in a future unit, but basically you have to put ide in front of or behind the element that you're using as the anion. All right, looking at the electron dot diagram, we're going to have Al here, 1 Al with 3 valences. Let's actually draw the valences in a different color. 1, 2, 3. And then we're going to have Cl. We have 3 of them. Let's see how well these will come out because it's so small. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. So note here that we're putting the electrons, so 1, 2, 3, 4, 5, 6, and 7, like that. We have to give one side 1 here, side 2 here, side 3 here, and side 4 here. It doesn't matter where you start, but you have to give each side 1 electron before moving on and giving it a second. So you put one here, 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 and here, and then you can go back and give another one to 1, 2, 3, and 4 respectively. Alrighty. So Based on this, we have 7 valences in chlorine, and give each valence from aluminum over to chlorine. Put arrows on that, and that's your electron dot diagram. Next on, we're going to do calcium. Calcium has a 2+ charge, and we're going to have nitride. All right, nitride is N3-, so we have a 3- charge. Just put that aside. And so based on this information, we know that we have 3 calciums for every 2 nitrides, so Ca3N2. Name is calcium nitride. And we have in our equation 3 calciums and 2 nitrides. So if we take a look at the electron dot diagram for this, it's going to be a lot, so bear with me. We're going to move over to this side here. And let's actually erase this top part because I want space. Alrighty, so we have here, we're going to have 3 of the calciums, each with 2 valences. I'll draw the valences here. 1, 2, 1, 2, 1, 2. And then we're going to have 2 nitrides, N. And if we look at our periodic table here, nitrogen is in group 5, so it will have 5 valence electrons. Nitrogen's right there, if you're still confused. It's in the group 5, so we're going to have 5 valences. So with this information, we can fill our valences in. 1, 2, 3, 4, and 5. We're going to have 2 nitrate, so we have another one here. 5 valences, 1, 2, 3, 4, 5. Make sure to give each side 1 before you give another. And we're going to connect the dots here. This one's going to go right over here. This one's going to go right over here. This one's going to go right over there. Alright, same deal with this calcium. One's going to go here. This one's going to go right there. And this one goes right there. Alright, and that is your electron dot diagram for calcium nitride. Moving on to the third one. We're going to try chromium. Chromium. That will have a 3+ charge. And we're going to do oxide. Oxide, which has a 2- charge. So in order to balance this, it's kind of similar to what we've been doing, but chromium we need 2 of. Cr, that's chromium, 2. And for every 2, we need 3 oxygens, or oxides. So Cr2O3 is your answer. Name is chromium oxide. And in our equation, we have 2 of the chromiums and 3 of the oxides. Taking a look at this valence diagram here, we're going to have a Cr here and a Cr here. We have 2, and then we have 3 of the oxygens. Let's draw that here. All right, so we have 3 valences. Actually, I drew that too close. There we go. Cr, and that will have 3 valences as well. Then we have for each oxygen 6. Okay, I drew that way too close to each other as well. So oxygen and oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So each of these, one's going to go here, one's going to go here. Another one's going to go right there. Another one is going to go right there. And our last 2 will go here and here. And that's our electron dot diagram for chromium oxide. Moving on to ammonium. Ammonium, do not confuse this with ammonia. Ammonium's NH4+. Alright, and we're going to do for the anion, we're going to do sulfate. Sulfate is SO4 2 minus. And so for every one sulfate, we're going to have two ammoniums because ammonium has a 1 plus charge, sulfate has a 2 minus. So NH4 2, we need parentheses here because it's a polyatomic ion, and we have more than one, SO4. So that is our answer, NH4 2 SO4. And so in our equation, we have two of the ammoniums and one of the sulfates. Chemical name is ammonium sulfate. And the electron dot diagram is as follows. So we're going to have, actually, I have a note to the side. Because these are polyatomic ions, luckily in Chem 1, you are not tested on. So you will not be required to draw electron dot diagrams for these polyatomic ions. And that's it. So moving on to our last example, we're going to do ammonium again. Ammonium, which is NH4 plus. We're going to have, instead of sulfate, we're going to do nitrate. And this is NO3 1 minus. So for every one ammonium, we're going to have one nitrate. And unlike this one where we use parentheses, since we have one of each, we're not going to use parentheses. NH4, NO3 is your answer. You have one of each. Name for this is ammonium nitrate. Ammonium nitrate. Alright, and same deal here. You are not tested on this because these are polyatomic ions. So not tested on. And that is it for practice.